Hi, this is Adam at Total Metrology. Today I'm going to show you some workarounds on how to use a Disc Stylus with your ZEISS CMM using a VAST XXT passive scanning probe head. This video series will be broken into two different ones. The first one we will focus on using the main disc for radial measurements, and then we'll do a secondary video that will focus on how to use the roller or the axial pin to do slot width measurements. So the big thing about this is it's not technically supported by ZEISS, so the process is not like your normal stylus qualification. So for the disc, you will not be using the reference sphere as you normally would. Instead, we will be using a ring gauge that you can see set up on the table here. Ideally, you want your ring gauge to be about the same diameter as the feature or features you're going to measure with the disc stylus. Also, you will need a reference stylus. When I say reference stylus, I don't mean, it doesn't have to be the master probe. It can just be any stylus that is of similar length and ideally similar rigidity to your disc stylus system. Before you go on to the next step, which we'll get to in a moment, you need to have the reference stylus qualified via the normal reference sphere method in the orientation that you plan to use your disc stylus. For today's circumstances, we're going to use the back orientation, so the probe would be pointed back in the positive Y direction, and that's why we have the ring gauge set up in this orientation. I'm going to fast forward a little bit and skip ahead to that point, then we'll get started on the next step. We need to go ahead and make a copy of our reference stylus. I chose a 3mm by 50 stylus that is fully qualified in the orientation I need for the disc stylus. As you can see here, it's green and says yes, it is qualified. I will make a copy of this. I will rename it 10mm disc. As you can see, the copy retains all the same styli, and more importantly, the stylus qualification statuses. As you can see here, they're all, well, not all are green because that one was not qualified. But the one that I need it's this number 7. And as you can see, it retained all of the geometry from the reference stylus. So we need to adjust a few of these things here for starters. The radius of our disc is a 5mm because it is a 10mm diameter disc, so 5mm radius. And for the Y, if you look at the SolidWorks sketch on the screen, I have on the top here a simple representation of what I chose for my reference stylus, and on the bottom is a sketch of the disc stylus. So I need to adjust the Y by the difference between the center of the spheres. So as you can see here, that is 13.5mm in my case. So I need to reduce the Y value, again, since it's a back-facing orientation. We're going to reduce the Y length by 13.5mm. So 272 minus 13.5, we're going to set this to 258.6949. And we're going to make the assumption that the X and Z values are pretty close to what they were on the reference stylus, again, because we're using the same orientation. So this is what we're going to use for our initial settings. I'm going to apply that, and now I will teach the chip ID. So I'm going to go ahead and do that. Okay. Now we need to set up the new probe in the probe rack. So we're going to set stylus system to stylus system holder. All right. Now we're going to go pick up our reference stylus. Actually, just to avoid a collision here, let me adjust one thing. Okay, now I'm going to pick up what I'm using as my reference stylus. Okay, we have a simple model of a ring gauge that we're using for this qualification. For my base alignment, I used the cylindrical ID of the ring gauge and the front face of the ring gauge. Both of those will be picked up by the reference stylus in the number 7 back orientation. So on my actual CMM, which I know you can't see at the moment, but I've selected that same stylus system. So again, my ring gauge, based on its the markings on the ring gauge, is 0.5625 inches, just to show you all of that. Now, for my base alignment, as I mentioned before, I'll show you that as well. So my rotation in space, the X origin and the Z origin are all using the cylindrical ID of the ring gauge. The front face is going to be used for the planar rotation and the Y origin. So once you have your base alignment and your clearance planes established, I will go in here now and add a circle, which will be measured with the reference probe. So I'm going to change this to circle ref stylus, and I will change the depth to 6. And again, we know this is 0.5625 inches. Let's check the strategy. Oh, that looks good. Clearance data, that also looks good. Okay, so for this we want to report out, again we're looking in the back orientation, so we want to know the position of that ID in the X and the Z, and then we want to know the diameter. So these nominals are okay. We do not need any tolerances for these because we are only using them for reference, and we will say okay. All right, now that that is done, I will go ahead and run this program. If you get this message here, that is because one of the styli, as you saw earlier, was not qualified. That's not a problem in this instance because we're only using the ones that were qualified, so I will hit OK. So we will clear existing results, start with a manual alignment using all characteristics. That looks good, so we will start that. Okay, now we have our first set of results. Again, these are only for reference. So that looks good. We're going to close that report. Now that we have probed and done our manual alignment and have the Y0 value set to the face, the front face of the ring gauge, now we're going to pick up the disc stylus and we're going to more finely adjust the Y length value We're going to do that by probing on the face of the disc. If you look on the SolidWorks model shown on the screen, we're going to probe the face of the ring gauge with this face on the disc. And since Calypso thinks this stylus is a full 10 millimeter spherical tip, the value that it's expecting to probe off the tangent point of this theoretical tip. However, instead we're going to be probing on this face. So based upon the specs for your disc stylus, you will be able to calculate the difference between where this face actually is and where this tangent point theoretically would be. So for our geometry for the disc stylus, that difference is going to be 4.4 millimeters. So that is the expected value. I have a spreadsheet that I use just to help keep things straight. So again, the reference value actual would be 0 since we zeroed out on that. The disc stylus value that we're going to probe, we're going to type that in here. Then our expected value will be 4.4. So now we're going to change the disc stylus. We're going to change to the number 7 back orientation. Then we're just going to manually drive over, and we're going to take a point with the face of the disc on the face of the ring gauge. And as you can see, it placed the point inside the ring gauge because it thinks it's probing on the 10 millimeter spherical tip. So if we look at the actual Y value of the point we just took, 4.4836. So we're going to type that in here, 4.4836. Again, based on the expected value of 4.4, we have a difference shown here. So if we look at the geometry of the stylus, the Y value, initial Y value, paste that in here. Then, so the adjustment to make the point read what we expect, we need to basically subtract the difference between the actual value and the expected value from the initial value. So this formula shows us we should change it to 258.6113. Apply that. We will delete this point, and we will take it again. All right, and as you can see now our actual Y value is 4.4. So that means we have the Y value roughly dialed in. Now we will focus on the X, Z, and diameter values. So in order to do that, I have another worksheet that collects data and does some calculations for us. So we have, actually first let me go ahead and delete this point because we don't need that anymore. So that the circle that we measured with the reference stylus, we're going to take and measure that same circle with the disc stylus. Then we're going to compare the values, the measured values between those two styli, and we're going to enter that deviation here. and then once we get to that point, I'll explain what the other calculations are doing here. So again, let's just make a copy of this feature. We'll go in and rename it to disk. And I want to go into the strategy and change the stylus system. That all looks good still. Except this time, we're going to report out the X, Z, and diameters with a tolerance. So for the purposes of our demonstration, we're going to use a tolerance of plus or minus 1 micron for all three of these characteristics. Okay. And what we're also going to do, again, because we want to compare directly to the values from the reference stylus, and those characteristics, we're going to come in and change the nominal to use a formula that will look at the actual measured values, and we're going to set that for the nominal for each of these. So again, change that to a formula for the Z value, actual, okay. Formula, diameter, actual. Okay, so now that that is ready to go, we are going to run the program once again, except we're going to use, again, same warning note here. Just okay that. This time we are going to uncheck clear existing results, because again, we want to maintain the results we have already collected. We're going to use current alignment and all characteristics. So we're going to go ahead and run this and see what kind of data we get. So I would point out once again, we used the actual measured values from the reference stylus characteristics as the nominal values for the disc stylus. So again, this X value is the nominal here, Z value is the nominal here, diameter value is the nominal here. So based upon that, we have our deviations, which we're going to use in the spreadsheet now. So basically, I will just copy into the cell minus 0.0495 millimeters, minus 0.0740 millimeters, minus 0.1169 for the diameter deviation. Excuse me. So as you can see, based on the formulas here, for the X and the Z, the adjustment value is simply the negative of the deviation. So we have a negative deviation, so the adjustment is a positive of that same value. And same here. However, the diameter, since we're measuring the diameter of the ring gauge, but we're actually adjusting a radius value, we have to take the negative of the value and then take half of that. So again, this is a positive half of this value. Then we have the initial values that we need to go get from Calypso. So in this stylus, so we have the X value, actually, yeah, so these are already set. So then this final value calculation is what we're going to adjust the stylus data in Calypso to match. And as you can see in the formula, it takes the initial value and adds the adjustment value. So we're going to simply copy these over into Calypso. And we will apply these. Now we will delete the actuals from only the Disc Stylus circle. And now we're going to run the same program again. This is an iterative process, so we're basically just going to keep looping through this until the values are acceptable. So we will run this again using a current alignment. We do not want to clear existing results. We will start it now. Here we have our second set of results. As you can see, we're getting a little bit closer. The deviations will now be copied over into the spreadsheet in the deviation 2 column. So for the X, we have a positive 0.0116 millimeters. For the Z, we have a negative 0.0066 millimeters. And for the diameter, we have a positive 0.0003 millimeters. Again, the spreadsheet does the same calculations again. The initial value in this column is using the final value. As you can see, these values match the initial values for the second iteration. And again, the final value is simply the initial value plus the adjustment value. So again, we're going to copy these values over into the stylus for X, for Z, and the radius. We will apply these and run it once again. But first we will delete the actuals, and now we will run. Okay, we have our third set of results, and we're just going to do the same thing. We're going to copy our deviations over into the third iteration for the spreadsheet, 0.0005, 0.0015, and minus 0.0003. Make the adjustments in Calypso. For X, Z, and the diameter. I'm sorry, the radius. We will delete the actuals for the circle with the disk and rerun the program. So as you can see, we have everything green. This means that we have now qualified the X value, the Z value, and the radius. So we've tweaked those in to yield acceptable results. We also tweaked the Y value previously. However, as you may recall, the Disc Stylus diameter was used, and we have now adjusted that in here. So if you would like it to be a little more accurate, again, this is really only intended to make sure that when you go to set a Y depth for these measurements, when you're using the Disc Stylus, it's just to make sure that you actually land where you intend to land and don't have a collision. So this doesn't have to be perfectly accurate, but for explanation purposes, I'll go through adjusting this one more time. So if we look at the radius value, we can take and copy that into the spreadsheet using a formula equals the radius times 2. Again, our disc thickness, we're still using the nominal from our specs for the disc as 1.2 millimeters. So that theoretical difference, again shown from the SolidWorks model, would be about 4.4 millimeters, but again, the settings we ended up with were not quite 10 millimeters exactly. So if I go back to the spreadsheet, now my expected value is 4.4585. And now we're going to probe the face of the ring gauge with the face of the disc, just as we did before. Okay, our actual value we will put in the spreadsheet, 4.4639. So you can tell that is a difference of 5.4 microns, and based on the initial value that we had and this difference, the spreadsheet says we should adjust the Y value once more. Now we will delete that point, and we will take a new point for comparison. Okay, and the new value is 4.4587, which again gives us submicron accuracy, so that's good enough for this Y value adjustment. Now that that's done, just for final confirmation, we will delete that point. We will delete our actuals once more. And again, since we adjusted the Y position, let's just make sure it's coming in and scanning the same circle that the reference stylus did. So we will run the program one final time just for confirmation. As you can see here, we ended up a little high on the X value. So let's use this spreadsheet once again. Minus 0.0023 on the X deviation, minus 0.0007 on the Z, and 0.0001 on the diameter. We'll make a hopefully final adjustment here. Actually, we will leave this value alone. Apply that. Delete our actuals. And run it once again. So our final deviation numbers were 0.0007 minus 0.0003, 0.0002. Now I will run it 2 more times just to check the repeatability. Delete actuals. Fairly consistent, 0.0008 minus 0.0004. 0.0002 on the diameter, and one more time. 0.0009 minus 0.0002, 0.0003. Alright, so it's fairly consistent. So we're going to consider that good. We met all of our criteria, and repeatability was pretty good. So there you have it. Now you know how to qualify your Disc Stylus on a ZEISS CMM using a VAST XXT passive scanning probe head. An important thing to remember, though, is that you cannot requalify the stylus using the normal routine because it'll more than likely crash your CMM, and nobody wants that to happen. So I hope you found this information useful, and if there's ever anything that we can help you with here at Total Metrology, please visit our website at totalmetrology.com. There's also a link to the website in the video description. Thank you. Have a good day.